Good morning, Year 12. Hopefully by now you'll have been through the PowerPoint and you'll know a wee bit about what atom economy is. Remember that most chemical reactions produce 2 or more products, but often we only want one. Therefore, there's a lot of waste, and atom economy is a measure of how much waste there is. So really, we want to have as high an atom economy as possible. The higher the atom economy, the lower the waste, and only be a good thing. Now, if you look at the top of the slide there, atom economy is the mass of the product you want, and the question will always tell you that, as a percentage of the mass of all the products you make. So therefore, like I said before, the higher the atom economy, the more of the product that we are getting that we want, and the less of the product that we're getting that we don't. Now, if you look at the next slide, there's the formula that you should have copied into page 100 to work out atom economy. So it's going to be the mass of the useful product divided by the mass of all the products times 100. Now, if we look at the example that's on the slide, we are looking at this equation that produces calcium carbonate, and it also produces carbon dioxide. It's jumped down into the next line for some reason. Now, what we need to do is calculate the molecular mass of all the products. So I'll need the periodic table, and I'll go and look at the top numbers. If I add calcium's top number and oxygen's top number, we get a molecular mass, or a relative formula mass, of 56. If I do the same for carbon dioxide then, 1 carbon and 2 oxygens, if I add together those top numbers, I get a molecular mass, or a relative formula mass, of 44. Now, if I want calcium oxide as my useful product, well, I'm putting the mass of the useful product, the calcium oxide, that's 56, dividing it by the total mass of all the products, that's the calcium oxide and the carbon dioxide. So 56 plus 44 on the bottom line gives us 100. If I work that out as a percentage then, the atom economy for this reaction is 56%. So it's quite a lot of waste. We would want our atom economy to be as close to 100%. At the next slide then, I've got another reaction. This time we have got magnesium reacting with oxygen to give us magnesium oxide. Now, if you notice here that we only have one product, so therefore, because only one product is formed and it's the product that we want, the atom economy is obviously 100%. Now, if we look at the next equation that I'm underlining in red, this time we've got iron oxide reacting with carbon monoxide to form iron and carbon dioxide, and we covered this reaction a way back at the start of the year when we studied the blast furnace. Now, the product that we want is in blue, and it's the iron, but we've got to be careful this time because we've got to take into account the numbers in front of the product, the balance in numbers. So this time we have got 2 moles of iron being formed, and this has to be taken into account when we are calculating the atom economy. Now, iron's top number is 56, so therefore 2 times 56 is this 112. We worked out in the last equation that carbon dioxide's molecular mass is 44. This time we have 3 times this, which is 132. When I add these 2 numbers together, I get the number then on the bottom line, which is 244. So this time the atom economy of the iron product that we want is 112 divided by the total mass of all the products, which is 244, and it works out then, when I write it as a percentage, as 45.9%. Again, quite a lot of waste in this reaction. Like I said before, we want our atom economy to be as close to 100% as we possibly can, because this indicates less waste, and now if we look, therefore, is more sustainable. Now, if you turn in your books to page 102, I'm going to work through a couple of examples with you. Now, question 1 tells us that chlorine reacts with sodium hydroxide to form sodium chloride, water, and sodium chlorate. Now, sodium chlorate is used in bleach and is the desired product. So it's a good idea to underline the desired product. Now, we've got to use the periodic table. We've got to look at all the top numbers, and we've got to work out the molecular mass or the relative formula mass of each of these products. Use your periodic table, pause the video for a minute to do that. So when I go through and I work it all out, sodium chloride's relative formula mass is 58.5. Water's relative formula mass is 18. And the desired product, the sodium chlorate's relative formula mass, is 74.5. Now you've got the formula for atom economy at the top of the page in example 1. Remember that it's the mass of the desired product. So if I want to work out my percentage atom economy, that's going to be the mass of this sodium chlorate divided by the total mass of all the products. So I've got to go and I've got to make a total of 58.5, 18 and 74.5. When I total that up, I find that it totals up to 151. Then I go back to my atom economy equation, and the bottom line I pop the mass of all the products. I'm working out a percentage, so multiply the whole thing by 100, and the atom economy works out at 49.34%. And it's a good idea always to give your answers to 2 decimal places unless the question states otherwise. Now, there were no balancing numbers in front of these products, so therefore I want to skip ahead to page 103, 3 on page 103, because there are some balancing numbers to be taken into account.